Okay, this is just going to be a video showing you how to find the complex transfer function of a circuit like this. Okay, so the complex transfer function is it's a voltage divider. When you have a simple circuit like this is all I'm experienced with. So it's a voltage divider, and we want to find the gain, and gain is V out over V in. So a voltage divider would be V out equals V in times the resistance over this impedance plus the resistance. Okay, so that's quite easy to do. So we'll start by saying V out equals V in multiplied by R, and we'll say Z CL, that's the impedance, plus R. Okay, now I'm just going to divide by the V in, so that'll give us V out on V in R over Z CL plus R. Now, I'll rewrite this as gain okay, and at this point we need to get a proper value here for the parallel impedance of the capacitor and the inductor. So we'll just write that on the side. Let's try this just here. So ZCL equals, let's bring this down so we can see it. So it's J omega L for the inductor multiplied by 1 over J omega C, and that's over J omega L plus 1 over J omega C, and then that becomes J omega L on J omega C, just over the same thing. Now we're going to times the top and bottom by J omega C, so that puts J omega L, I'll just write it like this, times the J omega C by the 1 on J omega C, which would give you 1, so it's 1 plus J squared omega squared times by this term now, and then CL, but we know that J squared is minus 1, so that makes it that is ZCL. Okay, now we can return back up here using that, so we'll write R over J omega L. I'll just write it the other way around. I'll put the R over, this doesn't change anything, it's just how I've seen it written most of the time. J omega L 1 minus omega squared CL, and then I'm just going to divide by R. This is right, but we can simplify it. So I'm going to divide top and bottom by R. So I'm going to times top and bottom by 1 on R, which leaves 1. 1 plus 1 on R outside of this J omega L over 1 minus omega squared CL. And that is the complex transfer function.